Quadratic function. Given set of points -1, 6, 0, 3, 1, 4, 2, 9 and 3, 18. Show that the given set of points represents a nonlinear relation. Find the equation of the curve representing the given data. Now there are two parts to this question. First one is to prove that the data does not represent a linear relation. And second is to find equation of the curve where these points lie. Now we can do finite difference, and if the first finite difference is constant, then the function is linear, but if it is not, then it is non-linear. But we need to continue with this process since we need to find the equation of the curve. If the second finite difference is constant, then the curve is quadratic. If the third is constant, then the curve is cubic, and accordingly we need to find the definition. So let's start with finding finite difference from the given data. How to find finite difference? Let's look into that process. So we'll make a table, right? And we can write in the values which are given to us, the x and y values. So we have x values and the y values. We'll start with -1, 6. So we have -1 and 6, 0, 3, 1, 4, 2, 9 and 3, 18. Now finite difference means we have to do kind of y2 minus y1. That means we are subtracting from 3 the previous term 6. That is finite difference, right? And then we'll continue this process. We'll do 4 minus 3 and 9 minus 4 and 18 minus 9 and check what we get. So that is what we call finite difference. Let me represent this by delta, right? So that delta represented here, I'm writing first finite difference, right? So what I'm trying to do here is basically y2 minus y1. This is what I'm trying to do here, right? Let me extend this table like this. So what is 3 minus 6? So 3 minus 6, so we are trying to do 3 minus 6, which gives us equals to -3. And then we do 4 minus 3, which is equals to 1. And then we do 9 minus 4, which is equals to 5. And 18 minus 9, which is equals to 9. Right? So we get these values, which are -3, 1, 5, and 9. Since they are not the same, they're not constant, it is non-linear. So this itself means non-linear, right? Now as we have to find the equation of the curve, we have to continue this process, and let's now therefore find the second finite difference. So for second finite difference, we'll continue the same process, and this time it will be y2 minus y1, and these are our terms which we got, right? So these are the values which we have to take away, and let's find what do we get from these. So 1 minus of -3 gives us 4, and 5 minus 1 gives us 4, 9 minus 5 also gives us 4. So what we did here, let me write it down so it's absolutely clear to all, and that is we did 1 minus of -3, which gives 4 to us, right? And then we did 5 minus 1, 5 minus 1, which is equal to 4, and then we did 9 minus 5, 9 minus 5. That was 4. Now since the second finite difference is constant, which is 4, we say it's quadratic in nature, right? So second finite difference is constant. So we have second finite difference is constant, right? Therefore, this is quadratic, right? Let me write function. It's a quadratic function. Now, let's try to find equation of the quadratic function, right? So this is the next part. So we've done the first part of it, and then let's do equation of quadratic function. So in general, the equation of quadratic function can be written as y equals to ax square plus bx plus c. So that is the general equation of quadratic equation. Now we have three constants, a, b and c, rather three unknowns in this equation. To find values of three unknowns, we need three different equations. So what we should do is select 3 points. The points which are good to select for us are actually those where the x values are kind of easy to work with. So let's select these 3 points and then figure out the equation. So first one is minus 1 and 6. So when I say minus 1 and 6, that means 6 is my y value. So I write 6 equals to minus 1 is x value. So I write minus 1 square plus b times minus 1 plus c. And that gives us equation 6 equals to minus 1 square is 1. So write a minus b plus c. Let me call this as our equation number 1. Rather, this is my equation number 1 and I'll call this as equation 2. Okay. Let's use the second point, which is 0, 3. Now if I use the second point 0, 3, what do I get? 3 is the y value, so I write 3 equals to 0 is x value, so it's a times 0 plus b times 0 plus c. That means 3 is equals to c. So we get the value of c from here, right? So let me call this as equation 3. So equation 3 in fact is the value of c. Now we can use the next point, which is 1, 4. So 1 and 4, what do we get? If I place 4, 4 is the y value, I get 4 equals to 1 is the x value, a times 1 square plus b times 1 plus c. So I get 4 equals to a plus b plus c. So that gives me equation 4. Now with these equations, we can solve for the unknown a, b, c. Now if you see, we already have the value of c as equals to 3. So we have c equals to 3, which we have already worked. So if I put c equals to 3 in my equations and then I use equation number 2 and 4, and then I use equation 2 and equation 4, right? Then what do we get? So let's put 3 as the value of c in equation 2 and 4 and find out what do we get. So we get 6 equals to a minus b plus 3, and that really gives us 3 equals to 6 minus 3 equals to a minus b, right? And if I substitute the same thing in equation 4, which is c as equals to 3, what do I get? I get 4 equals to a plus b plus 3, or I get 1 equals to a plus b, right? So I get 2 more equations, which are equation number 5 and 6 for me. Now from these equations, we can find the values of a and b, right? If I add them, if I add equation 5 with 6, then I get 2a and minus b plus b is 0. 2a equals to 4, so I get 4 equals to 2a, or I can write a equals to 2, right? So that is the value of a for us. So let me say equation 7, right? Now once we know a is 7, we can substitute that in 6, right? So we'll sub 7 in 6, correct? To get our answer for a. A we know 2. B is equals to then 1 minus a, right? So 1 minus a, which is 1 minus 2, and that gives us minus 1. So we get b as minus 1, right? So finally, we get all our answers, and that is, we already know c equals to 3, b equals to minus 1, and a equals to 2. Given these 3 things, we can write down our equation. So let me push the page a bit forward. So we get our equation from equation 1. So we have y equals to a as 2. So we have 2x squared b is minus 1, so minus x, and c is 3 plus 3. So y equals to 2x squared minus x plus 3 represents the curve, rather a parabola in this case, which will contain the points minus 1, 6, 0, 3, 1, 4, 2, 9, 3, 18, right? That is how we can get equation of the curve representing those given points or the data. Let's go through this process once again to understand what we really did. First part of this question was to show that the points represent a non-linear relation, right? So first part was non-linear relation. That really means that first difference, that means this, that first difference is not constant. So we got this, right? That is non-linear since first difference is not constant. So that is the first part, non-linear, first difference not constant. So let me write down here, we have first difference not constant. And that means really non-linear. Now the second part of this equation was to find the equation of the curve. And therefore we continued with finite difference process, and we found that the second difference is constant and it is equals to 4. Now when it is equals to 4, we can find a quadratic equation to represent the data. General form or the standard form of quadratic equation is y equals to x squared plus bx plus c. Using 3 points from the given data, we can find the value of 3 unknowns a, b and c. Best points to select are with x values of minus 1, 0 and 1. And then we got our equation by following systematic process of elimination and substitution. That is what it is. So go through this video once again, and then we'll move on to slightly difficult questions where minus 1, 0 and 1 values of x will not be given to us. So it won't be that simple to figure out, but it will be more of a practice on elimination substitution method. Thank you and all the best.